Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA November 2022, Paper 1, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1, circle the length of time between 4 p.m. and 5:05 p.m. Well, between 4 and 5 p.m. that's 1 hour, isn't it? And 1 hour is 60 minutes. So between 4 and 5, that's 60 minutes. And then between 5 and 5:05, that's an extra 5 minutes, isn't it? So altogether, that is 65 minutes. It's that one. Question 2, a circle has diameter 10 centimeters. Circle the radius. Okay, so if I quickly just sketch a circle like this, center of the circle is here, then our diameter is a straight line that passes from one side of the circle through the center out to the other side there. That's the diameter, and we're told here that the diameter is 10 centimeters. Okay, now what's a radius? A radius is a straight line, and this time it joins the center of a circle to its edge, so it looks like that. So that's a radius. Now, because diameter goes from one side to the center to the other side, and the radius goes from the center to the other side, you can fit two radiuses in a diameter. In other words, the radius must be worth half as much as the diameter, which is 5. It's going to be that one there. Question 3, circle the percentage that is between a half and 3/4. Well, a half as a percentage is just a fraction over 100, so I can rewrite this as a fraction over 100. Now, 2 goes into 100 50 times. So if I multiply the top up by 50 as well, I'm going to get 50 over 100, which is the same thing as 50%. So half is 50%. What about 3/4? Well, 3/4 I could rewrite as a fraction over 100 as well, simply by multiplying the denominator up by a factor of 25, because 4 goes into 125 times. So doing the same thing with the numerator, times in that by 25 as well. 3 25s are 75. So 3/4 is the same thing as 75 over 100, which is 75%. Okay, so our number must lie between 50 and 75, and there's only one there that does, and that's 60 there. So the answer is 60. Question 4, circle the value of 3 squared plus 4 squared. Well, 3 squared is 3 times 3, and that's 9. And 4 squared is 4 times 4, and that's 16. And 9 plus 16 is 25. So it's that one. Question 5, simplify fully 8a plus 5b plus 6a minus 2b. Okay, so this is a question on collecting like terms, and I've got two types of terms here. I've got terms in A and I've got terms in B. Okay, so collecting the A terms together, 8a plus 6a, that gives me 14a, and 5b minus 2b, that minus sign belongs to the 2b. Signs belong to the terms that follows them, so that's why when I highlighted them, I highlighted the sign in front of them as well as the term. Okay, so 5b minus 2b, that's 3b, so 14a plus 3b is my answer. 14a plus 3b. Question 6. 200 students were each asked about the monthly cost of their phone contract. Here are the results. So school students, 40 of them had contracts less than £25, 90 had contracts over £25. With college students, it was 32 had contracts less than £25 and 38 had contracts more than £25. Part A says, how many more school students than college students were asked? Well, we need to have a total number of students to work that out. So we're going to add another column on the end of here called total. And then 40 plus 90, that gives me 130 students from school. And 32 plus 38, that comes to 70. And that's the number of college students. So how many more school students were there than college students? Then that is going to be 130 minus 70. That's the difference between the two then, isn't it? And that comes out to be 60 students. Okay, so there's 60 more school students asked. Part B says, what percentage of the 200 students had a monthly cost less than £25? Right, so again, I need a total. So if I make a total in this direction as well then, so 40 plus 32, that gives me 72 students had a total less than 25. And 90 plus 38, that's 128 students had a contract over £25. And adding those together, that gives you your 200 students, doesn't it, overall? So that's a kind of like the total in both directions. So as a percentage, well, as a fraction, it's going to be the 72 students whose contract cost less than £25 over the 200 students there were altogether. Okay, so as a fraction, it's going to be 72 over 200. But remember, percentages are out of 100 and not 200. So we need to divide by 2 between there and there. And dividing 72 by 2 as well. 72 divided by 2, half of 72 is 36. Okay, so 36 out of 100, that is the same thing as 36%. So 36% had a monthly contract which costs less than £25. Question 7. The only animals on a farm are 30 cows and 80 sheep. 1/5 of the 30 cows are sold and 5/8 of the 80 sheep are sold. Work out the total number of animals that are sold. Okay, so we want 1/5 of 30. Now 5 divides into 30, leaving 6. So that is 6. 6 cows are sold. Okay, and then 5/8 of the sheep. So 5/8 of the sheep are sold. Okay, so 8 goes into 80 10 times, and 5 times 10, that's 50. So they sold 50 sheep and 6 cows, so then the total number of animals sold is going to be 60 plus 50. It's 56, isn't it? So that's the total then. 56 animals were sold. Question 8. Some gamers were asked which type of video games they preferred. 65% said action, 19% said role-playing, the rest said sport. What percentage said sport? Well, percentages are usually out of 100, and we've got 65 plus 19 already allocated. So if we added those together, 65 plus 19, 5 and 9 is 14. So 1, 6 and 1, that adds up to 8. So between action and role playing, we've already accounted for 84% of the total. Okay, so then what's left out of 100? So if I take 100% and I subtract 84%, that leaves me with 16%, doesn't it? So it must be 16% like sport. Okay, question 9a. A diagonal of a rectangle is drawn on the centimetre grid. The sides of the rectangle are on the grid lines. Work out the area of the rectangle. Okay, so if that is the diagonal of our shape, then the rectangle is going to look like, it's going to have lines here and here. Oops. And also lines here and here. So that's our rectangle then. So this is a 4 by 3 rectangle. It's 4 units in that direction, 3 units in that direction. So what's its area? Well, area of a rectangle is length times width, which in this case is 4 times 3. So it's going to have an area of 12 unit squared, centimetre squared, I guess. Each one of those must be a square centimetre. Okay, so that's 12 centimetres squared. Part B says one side of a parallelogram is drawn on the centimetre grid. The parallelogram does not have any right angles. Complete the parallelogram so that it has an area of 24 centimetres. Okay. Well, the area of a parallelogram is base times height. Okay. So, and that is going to have to be equal to 24. Okay. That's going to have to be equal to 24. Now we know the base, because the base is the same as the top of it, and that's 1, 2, 3, 4, 5, 6 units along, isn't it? So the base is 6. So then what must the height be then, so that it has an area of 24? Well, 6 times what is 24? It's going to have to be 4, isn't it? So I know that the height must be 4. So I must have like 4 squares going this way, and my 6 squares going this way to make my parallelogram. Okay, so as long as I draw my other line 4 centimeters away from the top one, it should have an area of 24. Okay, so I'm just going to draw a line somewhere along this line which is 6 squares long. The only place it can't start is the same as the one above, otherwise it would be a rectangle. So you have to kind of come in a little bit. Maybe I'll start from here, 1, 2, 3, 4, 5, 6 in that direction, and then I can join it up and make my rectangle and my parallelogram up here. Okay, it doesn't have to be exactly the same as mine, as long as you've got 4 little squares between the top and the bottom, and your bottom line is also 6 centimeters. You should be fine. Okay, so there we go. And that's what mine looks like. Yeah, so there we go. Finally, part C says 2 sides of a rhombus are drawn on the grid. Complete the rhombus. Okay, well, a rhombus is a pushed over square or a diamond shape. So it's going to have a line of symmetry running down here. This is going to be a line of symmetry. Okay, so basically if I reflect those 2 lines in that line, then I'm going to get my diamond shape or my rhombus. Okay, so it's going to have a line like this, and then this way. Question 10. Here is a calculation. 428 times 30 is 12,840. Use the calculation to help answer the following questions. Write down the answer to 12,840 divided by 428. Well, that's just... this is the same as this, isn't it? And this is the same as this. So 428 times 30 is that big number. So that big number divided by 428, that's just going to be 30 again, isn't it? All right. And circle the answer to 214 times 30. Well, the relationship between 214 and 428 is half as much, isn't it? If you half 428, you're going to get 214. So therefore, if I half 12,840, I should get the answer. So half of 12,840, that's 6,420 then, isn't it? Okay, it's going to be that one there. Question 11. A shop sells notebooks and pencils. Notebooks come in packs of 8 and they're for £12. Pencils are 56p each, or you can get a pack of 6 for £2.70. Marek buys some packs of notebooks. The cost is £60. In total, how many notebooks does he buy? Okay, well, how many times does 12 go into 60? Well, 60 divided by 12, that's 5 times, isn't it? 5 12s are 60, so 60 divided by 12 is 5 packets, or 5 packs. Now, each pack contains 8 notebooks, so 5 times 8 is 40. It's going to have 40 notebooks. Okay. Part B says work out the cheapest cost of 10 pencils. Well, there's 3 different things you could do here. You could buy 10 pencils at 56p each. So 10 single pencils at 56p. Okay, that's one thing you could do. Or you could buy 1 pack of 6 and you could buy 4 singles. So 1 pack would be £2.70 and the 4 singles would be at 56p again. Or you could buy 2 packs at £2.70, and that would give you 12 pencils. It's more than what you need, but maybe it works out cheaper. They would be the 3 things that I would try. Okay, so first off, 10 singles at 56p. That's going to be 560 or £5.60, isn't it? That one, just times in 10 by 56. 4 lots of 56p and £2.70. What's that then? 56 times 4, 6 fours are 24, 5 fours are 20 plus 2 is 22. So that comes to £2.24 plus £2.70 for the other one. That is a total of £4.94. So this one costs £4.94. It's a little bit cheaper. Okay, £4.94. What about 2 packs at £2.70? No, that's too much, isn't it? That's £5.40. It's actually cheaper to buy 2 packs of 6 and buy 12 pencils than it is to buy 10 single ones. But overall, the cheapest one is buying 1 whole pack of 6 plus the 4 single pencils. So what is the cheapest cost then of those? That is going to be £4.94. That's the cheapest one. Part C says the shop also sells folder at £3.20 each. The shop has an offer: buy 3 folders, get another one for half price. Work out the cost of 4 folders using the offer. Okay, so you're going to get, if you're going to buy 3 folders and at full price, that's £3.20, £3.20 and £3.20. And then you're going to buy 1 at half price, half of £3.20, that's £1.60 then, isn't it? So we're going to have to add up those 4 costs. 0, 0, 0 and 0, 0. 2, 4, 6 and 6 makes 12, so that's 2 carry 1. That's 4, 7, 8, 11. £11.20. Okay, so the cost of 4 folders using the offer is going to be £11.20. Question 12a. A, B and C are connected by paths. The lengths of each path is shown. Nathan and Sue each walk from A to B. Nathan walks along the path A to B. Sue walks along the paths A to C to B. How much further does Sue walk than Nathan? Give your answer in kilometres. Okay, so let's have a think about Nathan first of all. Nathan is going from A to B. So A to B is this route here. That's just one route of 2.1 kilometres, isn't it? So that's equal to 2.1 kilometres. Okay. And then Sue walks from A to C to B. Now A to C is from here to here. That's 1.9 kilometre. 1.9 kilometres. And from C to B, that is another 800 meters, which is 0.8, isn't it, as a kilometre. So adding that together, that comes to 2.7 kilometres. Okay, so Sue walks slightly further than Nathan. How much further does Sue walk than Nathan? Give your answer in kilometres. Well, that's going to be the difference between the two then, isn't it? So if I take 2.7 and I subtract 2.1, that's going to leave me with 0.6. And so that is my answer then. So Sue walks 0.6 kilometres further. Part B says a straight path between D and E passes through P. DE is 200 metres. P is 60 metres closer to E than it is to D. Work out the ratio of DP to PE. Give your answer in its simplest form. Okay, so D to E, the whole distance then, the distance all the way from there to there, that is 200 metres. P is 60 metres closer to E than to D. 60 metres closer to E than to D. Now, if these were the same length, they would be like 100 and 100 between them, wouldn't they? Okay, but P we know is actually closer to E by 60 metres. But it doesn't mean that that's 40 and that's 160, because that, you can't just take 60 off and add it onto there. The distance 40 and the distance 160 is not 60 different. Okay, so it's not just knocking 60 off. Actually, what you need to do is knock half of 60 off. So if you knock half of 60 off of that one, that would give you 70, and that would give you 130. So then the difference between 130 and 70, that has a difference of 60, because 70 plus 130 is 60. Okay, so P to E is 70, and then D to P is 130. So then the ratio of D to P to E, that is in the ratio of 130 to 70. We can scratch a 0, so that's 13 to 7. And I think that's about as far as we can get because they're both prime numbers, aren't they? So we're not going to be able to break it down any more than that. Okay, so 13 to 7. Question 13, Emma tries to simplify CD times 2. Here is her method. C times 2 is 2C, D times 2 is 2D, 2C times 2D is 4CD. What is wrong with her method? Well, it's a bit like she's thinking that it's distributive, a bit like it is with addition. So what she's done is this. So she's saying, well, 2 times C is 2C and 2 times D is 2D. So what I've got is 2C times 2D. But multiplication is not distributive over multiplication. It doesn't work. Now, you would do it like that if it was a plus. If there was a plus in the middle like that, that would work. That would give you 2C plus 2D. That would be fine. But with multiplication, it doesn't work. Multiplication is not distributive over itself. I guess I could just say CD times 2 is equal to 2CD. And I think I could put it in brackets. Multiplication is not distributive over itself. Question 14, work out 0.37 times 0.26. Well, I'm going to work out 0.37 times 0.26. Okay, there were 7 6s are 42, so that's 2 carry 4. 3 6s are 18 plus the 4 is 22, so that's 2 carry 2. And in the next row, I'm going to add a 0. 7 2s are 14, that's 4 carry 1. 3 2s are 6 plus the 1 is 7. Then adding those up, I'm going to get 2, 6, 9. Okay, now I've got 1, 2, 3, 4 digits behind the decimal point in my question. So I'm going to need 1, 2, 3, 4 behind the decimal point in my answer, which means I need another 0 there and a decimal point and one like that. So it's going to be 0.0962. Okay, 15a. Solve 11x minus 3 is equal to 6x plus 1. Okay, so this is probably like the hardest type of linear equation you need to solve because you've got unknowns on both sides and numbers on both sides. Okay, so first off, can you see I've got a 11x on one side and I've got a 6x on the other. So I've got x's on both sides. So what I need to do is I need to take the smaller one of those two away from both sides. So I'm just left with x's on one side. So if I deduct 6x from both sides, they'll cancel on that side. And on the other side, I'm going to get 11x minus 6x. That's going to give me 5x. So I've got 5x minus 3, and that is equal to 1. I've just got 1 left on the other side. Okay? So I've got 5x minus 3 is 1 now. To get rid of that minus 3 next to the 5x, I'm going to add 3 to both sides. So they'll cancel, leaving me with 5x on the left. So now I've got 5x on the left, 1 plus 3 is 4. And then finally, to get rid of that 5 next to the x, I'm going to divide both sides by 5. I'm just going to get, they'll cancel, leaving me with x on the left. I'm just going to leave it like that, 4/5. That's perfectly acceptable like that as a fraction. Why would you do anything else? So it's just 4/5. I mean, you could turn it into a decimal, but you'd just be wasting time because 4/5 is a perfectly acceptable answer. Part B says solve 2x over 5 is equal to 14. Okay, so 2x over 5 equals 14. Now, the first thing I need to do is get rid of that 5 at the bottom of the 2x there, and I can do that by timesing through by 5 both sides. Okay, so the opposite of dividing by 5 is timesing by 5, so they'll cancel out. That will leave me with 2x, and 14 times 5, well, that's 70. So I've got 2x is equal to 70, and then to get x on its own, I'm going to divide both sides by 2. That'll leave me with x on the left, 70 divided by 2, that's 35. Okay, so x is equal to 35. Question 16. Bag A and Bag B each contain only red discs and green discs. Bag A contains 26 red discs. There are twice as many red discs as green discs. Bag B contains 20 green discs. There are 3 red discs for every 5 green discs. Work out the total number of discs. Right, so bag A contains 28 discs, and there are twice as many red discs as green discs. So for bag A, let's just do bag A down here. Bag A, bagger. There's twice as many red discs as green discs. So the ratio of red to green then is in the ratio of 2 to 1. There's twice as many red discs as green discs. Now, if there are 28 red discs, to go from 2 discs to 28 discs, that's multiplying through by 14. If I do the same thing on the other side, times 14, then I can see that I've got 14 green discs. So in bag A altogether, so 28 plus 14 equals 38, 42, 40 discs altogether in bag A. Okay, so got 42 discs there. So let's switch to bag B. Bag B. Right, contains 20 green discs. There is 3 red discs for every 5 green discs. So then the ratio of red to green for this one is 3 to 5. And I know I've got 20 green discs this time. So 5 goes into 24 times. So we've scaled up this ratio by a factor of 4. So I do the same thing on the other side, times through by 4. 3 times 4 is 12. So that means I've got 12 red discs and 20 green discs. 12 plus 20, that's 32 discs in bag B. So then adding those up, 42 plus 32, that comes to 74. So there are 74 discs in total. Must be. Part B says a different bag C is empty. The 28 red discs from A are put into C. The 20 green discs from B are also put into C. 1 disc is now picked at random from each bag. Complete each statement. Well, probability of success is going to be successful outcomes divided by total outcomes. Okay, that's how you work probability out. Now, if we pick a disc at random from bag A, it used to have 28 red discs in it, but we took them out and we put them in bag C, so now it's got 0 red discs inside it. So the probability of you picking a red disc from bag A, that's going to be 0. There is no chance. Okay. In bag B, you used to have 20 green discs and 12 red discs, but we took the 20 green discs out, so the only thing left in bag B is the 12 red discs. So the probability of picking a red disc from bag B, that's going to be 1. You're certain of picking one, haven't you? So the probability of that one is 1. And then from C, what is the probability of picking a red from C? Well, there are 28 red discs, there are 20 green discs, so that means you've got 28 chances of picking a red disc out of a total of 48 discs. So the probability is going to be 28 over 48. Okay. Question 17. What is 1/20th as a decimal? Well, decimals are out of tenths, hundredths, thousandths. So we want to try and get our 1/20th as a fraction over 10, 100, or 1,000. If I divide it by 2, I'd get tens on the bottom, but then I'd get like 0.5 on the top. It's not very helpful. So I'm going to see if I can change it into hundredths. So 20 goes into 100 5 times. So 1/20th is going to be the same thing as 5 100ths. And 5 100ths is a decimal. 0 unit, 0 tens, 5 hundredths. So 0.05. It's going to be that one there. Divide 62 in the ratio of 3 to 7. Okay, so if you're dividing something into a ratio of 3 to 7, that means someone's getting 3 shares and the other person is getting 7 shares. So altogether, there are 3 plus 7 equals 10 shares, aren't there? Okay, so once you know there are 10 shares, the next thing to do is to work out the value of each share. And I can do that by taking the total amount to divide and dividing it by the numbers of shares. So that will tell me the value of each share. So 62 divided by 10, that is 6.2. So each share is worth 6.2. And so this ratio 3 to 7, I can just scale up by a factor of 6.2 to find the actual amount then, because one's getting 3 shares and each share is worth 6.2 and the other one's getting 7 shares and each share is worth 6.2. So multiplying through 3 lots of 6.2, what's that, 18.6? And then 7 lots of 6.2, 7 6 are 42, 7.2 is 1.4, so that's what, 43.4? 43.4. Probably a good job just to check that they actually both still add up to what we had to start with. Yes, they do. Okay, so that does seem to add up, so I haven't lost anything along the way. So what is the answer? It's 18.6 and 43.4. Question 19. N is an odd number. Why is n plus 1 always an even number? Okay, well, I guess because if n is odd, then n plus 1 is going to be 1 more than n. 1 more than each odd number is an even number. So n plus 1 is going to be even. Must be, mustn't it? So like, let's say n was 3, add 1 to it, you get 4, which is an even number. Let's say n was 7, add 1 to it, you get 8, which is an even number. So every time you add 1 to an odd number, you're going to get an even number. Okay? So you've got n, which is odd, and n plus 1 that is even. So n plus 1, that is equal to an odd number multiplied by an even number. Okay? Now, any even number times anything is going to be an even number. Think about the 2 times table. 2 is even. If you multiply it by 1, you get 2. If you multiply it by 2, you get 4. You multiply it by 3, you get 6. These are all even numbers. So an odd times an even, that's always even. Okay? So that is why we always get an even answer. Here is some information about the time spent on social media by 40 women and 40 men last week. So we got time spent, and that's been grouped together. We've got 2 to 5, 5 to 8, 8 to 11, 11 to 14, 14 to 17. And we've got number of men and number of women listed separately. So tick one box for each statement. 3 of the women spent more than 11 hours on social media. 3 of the women spent more than 11 hours on social media. Well, yeah, I mean, you can look at those there. The 2 spent between, well, more than 11 and less than 14, and the 1 spent more than 14 and less than 17. So yes, that's definitely true then. There are definitely 3 women who spent more than 11 hours on social media. Luckily, this one here is greater than. If it was greater than and equal to, then I'd probably have to tick might be true, but because it's strictly greater than, I can say that all 3 of those are definitely bigger than 11. Right, next one. The range for the men is 15 hours. Okay, so the highest guy is up here, look. So it could be as far up as, let's do that in green actually. So that's that one there. He's the highest, and that is 14. And then we've got 10 in the lowest category, which could be as low as 2. So if you then subtracted 14 away from 2, the maximum the range can be is actually 12. So saying that the range for the men is 15, no, that cannot be true. It's not possible. Okay, so that one's definitely not true. The women have a higher median than the men. Okay, well, we're going to have to work out the median then, aren't we? So we've got 40 men and 40 women. So the median is going to be like halfway through your data set. So 40 divided by 2, it's like the 20th, 21st women and the 20th, 21st men. So where did they go? Okay, so the first 12 women are in this category here, in the 2 to 5 category, and then the next one, next 11 are in here. Now together that adds up to 23. So I'm pretty sure the 20th and the 21st person, or the 20th and 21st woman, have got to be in that second category, haven't they? Because that takes you all the way up to person number 23. Okay, so for the women, the median is in the 5 to 8 group. What about the men? So the men, so again, I've got 10 in here and 17 in here. That takes me all the way up to 27. So they're also going to be in the 5 to 8 group. Okay, so exactly where the 20th, 21st person lies between that range of 5 to 8 is not clear. Okay, it might be the 20th, 21st women were slightly higher than the 20th, 21st men. You can't really tell from the data, so I'm going to tick might be true. The diagram shows the vector A and B, as a column vector, a equals 3, 2. Yeah, it is, because you can see if you're going from one end of a to the other end of a, you're going along 3 and you're going up 2. Can you see 3 along and 2 up? Okay, so that makes it a vector 3, 2, because in vectors, column vectors, x, the top number is in the direction of x and the bottom number is in the direction of y. Okay, so what is b as a column vector? So doing the same thing to b, how far in the direction of x is it from there to there? That's like 1, 2, 3, 4, isn't it? Okay, so that's 4 units in that direction. And then in the other direction, in the y direction, it's actually 1, but 1 downwards rather than upwards. So this as a column vector is going to be 4, because we're 4 units in the direction of x, but minus 1, because we're going 1 down rather than 1 up in the y direction. Right, and then it says work out the value of 4a as a column vector. Well, 4a is going to be equal to 4 lots of 3, 2. And when you've got a scalar like this on the outside of a column vector, you end up multiplying it by each of the numbers inside. Okay, so 4 times 3 gives you 12, and 4 times 2 gives you 8. So my final vector is going to be 12, 8. So 12 there and 8 there. Now part C says a plus c equals 3, 0. Work out the value of c as a column vector. Circle your answer. Okay. So let's write down what we know, and we'll put in some algebraic values for the ones we don't. Okay. So we know a, that is the vector 3, 2. I don't know c, so I'm just going to call it x and y. And I know what it's equal to. It's equal to 3, 0. Okay? So having a look at this, then this number here plus this number here should be equal to this number here. Okay? So because 3 plus x equals 3, it implies then that x is equal to 0. Okay? And then the other one, I've got 2 plus y, and that's equal to 0. Okay? So I've got 2 plus y equals 0. So what does that make y then? Y must be negative 2. Okay, so which one is it? It's got to be that one there. Then there's an x is 0, y is negative 2. Work out 7/10 minus 4/15 divided by 2/3. Okay, well, normally in bid maths we would do division first, wouldn't we? We'd do division and then we would do subtraction last. But because we've got brackets trump everything, so everything in that bracket is going to get done first. Okay, so we're going to do 7/10 minus 4/15 first, and then we're going to divide it by 2/3. Okay, right, so let's do the bracket first then. So 7/10 minus 4/15. Well, really we need a common denominator here, don't we? So what's common from 10 and 15? Well, I think they both go into 30. So if I times that one by 3 and that one by 2, that's going to give me 30 of everything, isn't it? So 3 7s are 21, 3 10s are 30, minus 4 2s are 8, 15 2s are 30. And then I've got divide by 2/3. I think I'm just going to use this as an opportunity to keep, change, flip. So I'm going to keep the bracket. I'm going to change the divide into a times. I'm going to flip the fraction over. So keep, change, flip is a kind of a mnemonic for that. Okay, so that's what I've done. Okay, now what? So let's do the subtraction in the bracket now. They're in the same denominator. So 21/30 minus 8/30. So I can just go ahead and subtract the numerators, can't I? And then keep the denominators the same. So 21 minus 8, that's 13. So 13 over 30 multiplied by 3 over 2. Anything I can cancel there? Well, I can cancel the 3 with the 30. That's going to give me 10 and 1. Nothing else to cancel. I've just got a 13 on the top, so I'm just going to go ahead and multiply now. So 13 times 1 is 13, and 10 times 2, that's 20. So I'm going to get 13 over 20. What's my final answer? Work out all the integer values of x for which 12 is less than or equal to 4x, which is less than 25. Okay. I think what I'm going to do is just going to divide everything by 4 to start with. Divide by 4, divide by 4, divide by 4. 4 goes into 12 3 times, so the left-hand limit becomes 3. So 3 is less than or equal to 4x divided by x they'll cancel out, won't they? Like that, leave you just with x. So 3 is less than or equal to x, which is less than 4's into 25. Well, 24 goes into 24 6 times, so it's 6 remainder 1, isn't it? So that's 6 1/4. I'm just going to leave it as a fraction. Okay. Right. So then, what are the whole values of x that it can take between 3 and 6 1/4? So our range, if you think about it, goes from here up to a little bit beyond 6, but we're only interested in the whole numbers anyway. Okay, so what whole numbers can it take? Well, it can take 3 because it's allowed to be equal to 3. It could take 4, it could take 5, and it can take 6, but it can't be 6 1/4. Okay, so it's going to be 3, 4, 5, and 6. Here is some information about 120 people who visit a shop. 3/4 of the people buy neither a coat nor a dress. 19 people buy a coat. 14 people buy a dress. Complete this Venn diagram to represent the information. So we've got the universal set, which is equal to 120. We know that C is the people who buy the coats, and D is the people who buy the dress. And we've got some blankety blanks to fill in on the diagram. Okay, is there anywhere we can start? No. All right, so I'm just gonna work through this. Then I've got 3/4 of the people who buy neither a coat nor a dress. I suppose we could start with that, can't we? That's a definite. That's going to be the bit on the outside. So what is 3/4 of 120? Well, dividing 4 into 120, that goes in 30 times, isn't it? So 4 goes into 120 30 times. 3 times 30 is 90. Okay? So, yeah, we've got that. And that's going to be the number on the outside then. Okay? Right, and so what else have we got? What else do we know? We know 19 people buy a coat. Okay? But we don't know what's in the middle. So when we've got a situation like this, where we know everything in the big circle, but we don't know the bit in the middle, the easiest thing to do is call that bit in the middle x. Okay? So then if I've got 19 people who buy a coat, then if I've got x of them in the middle part, then there must be 19 minus x here, so that when you add those two bits together, 19 minus x plus x, it gives you back your 19. Similarly, on the other side, 14 people buy a dress, so I must have 14 minus x who buy a dress alone, plus the x that buy a dress and a coat, giving me 14 minus x plus x equals 14 people overall. Okay, so now I've got something in each of the regions. I can use the fact that there are 120 people in the shop altogether. Okay, so I'm going to form an equation by adding all the various bits together of my Venn diagram and solving for x. Okay, so taking the 4 different regions, 19 minus x plus 14 minus x plus 90, the 4 different parts of my diagram, I'm going to say that that must be equal to 120, like it told me in the question. Okay, so then just collecting like terms then, I've got minus x, x and minus x, so that's minus x, and I've got 19, 14 and 90. Well, 19 and 14 is 104, plus 19 is 123. So I've got 123 minus x equals 120. So that means that x is going to have to be 3 then, isn't it? X is 3. So now I know that there are 3 people in the middle here, which means there must be 19 minus 3, there must be 16 people here, and there must be 14 minus 3, there must be 11 people here. Okay, so there we're done. Write 3 to the 6 times 3 to the 5 to 3 to the 7 in the form n to 1 where n is an integer. So this is a crazy hybrid indices ratio question. Interesting. So let's have a look at the bit inside the bracket first. I've got 2 numbers with the same base. So if I'm multiplying those together, it just needs to add those indices there then, don't I? So I'm just going to simplify that first. 3 to the 6 times 3 to the 5. Well, that is 3 to the 6 plus 5. That's 3 to the 11. So I've got the ratio 3 to the 11 to 3 to the 7. Now, if I want that to be 1 there, then I'm going to have to divide by 3 to the power of 7 then, aren't I, to get from 3 to the 7 to 1. So if I do the same thing on the other side, 3 to the 7, then I'm dividing 2 numbers with the same base, 3 and 3, so I just subtract the indices, 11 minus 7. So 11 minus 7, that's 4, so that's going to be 3 to 4, okay? Now it says n must be an integer, so I guess we need to work out what it is. What is 3 to the power 4? Well, 3 3's are 9, times 3 is 27, times 3 is 81, isn't it? So that's 81 to 1, so 81 to 1. Okay, there we go. A is 10% more than B. Circle the ratio of A to B. Okay. Well, if 8% is 10 more than B, but we don't know what B is, let's say B is 100%. Okay, so let's give B 100%. Then A is going to be B plus 10%, isn't it? And we know that B is 100%, so A is 100% plus 10%. In other words, A is 110%. Okay, so A is 110% and B is 100%. So then the ratio of A to B is going to be 110 to 100. Okay, just divided both those by 10 to simplify it down a little bit. I'm going to get 11 to 10. So that is the ratio of A to B then, isn't it? 11 to 10. It's going to be that one there. Question 27. Use trigonometry to work out the value of x. Okay. So whenever I do trigonometry, the first thing I do is I label the sides. Which sides have I got? And I always start with the long one because it's the easiest one to see. This is the longest side here. It's the hypotenuse, isn't it? So I'm going to label that one H for hypotenuse. Okay? Hypotenuse is always opposite the right angle, so that's another way of finding it, but usually you can pretty much see that which one is the longest side without worrying too much about it. Now the other two sides are labelled relative to the angle we've been given, and we've been given this angle down here, the 60-degree angle there. Okay, now this one over here is on the opposite side, so we call it the opposite, or O, and this one down here is joining on to the angle, so we call this one the adjacent. Adjacent means next to. Okay, so we've labelled up each of our sides. Next thing is to work out which trigonometric ratio that we need to use. Okay, now I usually write down my mnemonic for working that out now. So, ka, toa. Okay, there's some other ways to remember it, but that's kind of the way that I do. Now, which ratio I'm going to use? So I need my H, I want the A, I don't want O, don't know O, don't care about O. Okay, so what I tend to do is I think which one don't I want and get rid of all the ratios that have that one in it. So SOT has got an O in it, TOA has got an O in it, so it can't be either of those two. Going to have to be that one there, the K part, which is the cosine, isn't it? So once we've worked out which ratio to use, I'm going to write down the ratio itself. So cos theta is equal to the adjacent over the hypotenuse. Okay. Next thing is to sub in what we know from the diagram. So I've got cos 60 equals the adjacent, which is x, divided by the hypotenuse, which is 8. Okay? Now, what is cos 60? We've got a bit of a problem here because this is the non-calculated paper and I need to work out the cosine of an angle. Now, you have to know certain angles for the exam. So you have to know the sine, the cosine, and the tangent of 0, 30, 45, 60, and 90 for the exam. Now, there's a kind of easy way to remember them. The easiest way I think of remembering it is that the sine of your angle is just root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. So notice that I'm going 0, 1, 2, 3, 4 along the top. They're all square rooted and I'm dividing by 2 underneath. Now the cos of your angle is the same as the sine but reversed. So it's going to be root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. Now if you were doing the tangent, you would then use this one and you would divide it by this one to form the tangent. So the tangent would be root 0 over root 4, etc. Okay, but I don't need the tan, so I'm not going to bother to write it out. Should I? Well, let me just do it for completeness so you know for next time. So it'd be root 1 over root 3. This one would be root 2 over root 2. This one would be root 3 over root 1. And this one would be root 4 over root 0. Okay, now some of these would need to be resolved, but I'm not going to bother to do that for any that I don't need. The only one I need is cos 60. So reading across from cos and down from 60, then the one I'm looking for then is that one there then, isn't it? Because it's in the 60 and it's in the cos. So the cosine of 60 is root 1 over 2. Well, the root of 1 is just 1, so actually this just resolves to 1 over 2. It's a half. Okay, so the cosine of 60 is a half, and a half is equal to x over 8. Multiplying both sides by 8, I'm going to get x is equal to 4. And that's the answer. X is 4. Now, if you want to be able to answer the trigonometry questions on a non-calculated paper, there's no ways around it. You have to remember this table in one way or another. There are different ways of doing it. I think the way I've just written it down is probably the easiest way to remember it. But yeah, you're going to have to memorize it. Sorry about that. It's not going to be on your formula sheet. You're going to have to be able to reproduce it. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.